Hey everyone, you've made it to the last video of lecture 6, so congratulations on getting here. And today we're really going to round out this lecture and talk about how the different policies, taxes and subsidies in particular, can help address our externality problem, right? Because we can't, expect people out of the goodness of their hearts or firms out of the, just to out of nowhere decide to implement policies or change production practices that respond to these externalities, especially when they're not profit maximizing, right? Or they're going to hurt the firm's bottom line. And so, oftentimes, it's the role of the government to step in and provide policies that incentivize the change from a private equilibrium to a social equilibrium, because that's going to be a welfare maximizing state to get to. And there's three common ways that governments can basically intervene into these markets and generate more efficient market equilibrium. Okay, and so the first is an emissions standard. So a standard is basically like a quota. It prevents production past a certain point. It's a hard cap on production, right? And you can imagine, because we saw in the previous video, that the socially optimal quantity is lower than the privately optimal quantity in a market. A quota is basically just going to say, okay, what's the hypothetical socially optimal quantity? We're setting a quota at that point. And there's a bunch of reasons why actually a quota is not really the best policy to implement for these types of situations. And we won't go over them now in the bootcamp, but it's something to be thinking about going into the semester as to basically emission standards are often only used in cases where there's sort of policy hurdles to get through with taxing. Taxes are not a very politically favorable term, and so there's certain situations where a standard does make sense, but oftentimes it's not the most efficient from a welfare standpoint. Okay. The second is a tax, or in the case of a subsidy, sort of a reverse tax. And so the government can tax the externality directly. For example, we can tax every unit of gasoline or every gallon of gasoline that's put into a car. We can tax every unit of paper that's made, because paper maybe produces some gunk, like we saw in the last video. Basically, this tax is going to require firms that produce this externality to pay a certain tax per unit. And the firms may or may not choose to pass on all or some of the tax to consumers, but as we showed earlier in this lecture, it doesn't exactly matter in theory who the tax is placed on. We're still going to arrive at the optimal solution from a social standpoint. Okay, taxing an externality is often is called a Pigouvian tax. So if you hear the term Pigouvian tax, that's the term that's used for a tax on an externality. Okay. And the final system is a cap and trade system, which is actually we see in several parts of the world now in regulating externalities. In California, in particular, we have a cap and trade system for our electricity sector, so emissions from electricity generation. But Canada and Britain also have different forms of cap and trade systems, so they're becoming more common. So a cap and trade system is basically a combination of a standard and a tax. What basically happens is the government sets an industry cap on total emissions, or whatever externality produced may be, and then lets the firms in that industry trade permits associated with the production of the good generating the externality. So in the case of the California electricity system, you have a bunch of firms producing electricity. Each of the firms has a certain number of permits that allow them to produce a certain number of units of electricity, and the firms can trade these permits around based on which firms are essentially the most efficient producers of electricity. Those firms will pick up permits, and the less efficient firms producing electricity will sell permits, because it's more expensive for them to produce than it is for them just to sell the permit and be done with it. Okay, so this is a good system to incentivize efficiency of production. Okay, so in this video, what I want to do with the rest of the time is talk about how a tax implemented on a specific externality leads to the efficient solution we saw in the previous video, where we get to the socially optimal equilibrium point. Okay, and so let's again assume we have a negative path of pollution externality. And oftentimes when we draw externality graphs, especially negative externalities, we're going to be thinking about taxing the production side. It's just a lot easier. It's more centralized, and oftentimes we think about the production itself as the thing that's generating the externality. So Of course, you can think about taxes and subsidies on the demand side, but for this initial setup, we're going to consider it for the supply side. Okay, so let's draw our usual situation. So we have our demand, we have our marginal private cost, we have our marginal externality cost, and the combination of the two giving us our marginal social cost. The curves I've drawn are arbitrary. You're going to see different forms of different types of curves. Sometimes the marginal externality cost will be constant. And so this is just a generic setup, but I want you to know that there can be flexibility in how these curves are drawn. Okay, and so we know that the intersection between the marginal private cost and the demand generates our competitive equilibrium. And we want to get to the point where the marginal social cost is intersecting the demand, right? We want to get to this point. And when I say we want to get to this point, that implies that the private market without any government intervention is not going to naturally get to the point where marginal social cost is equal to demand. Okay? That's super important because the entire idea behind a private market is that the firm is operating, based on their marginal private cost curve, based on their supply curve, and so that's what the market's operating under. And consumers are just operating under their demand, so there's a market demand. And without any additional incentive or regulation, there's no reason for the firm to deviate away from this private equilibrium. Okay, and so how can we do this? Well, we want to put a tax into place that gets us from the competitive equilibrium, which I'll call equilibrium A, to the socially optimal equilibrium, which I'll call equilibrium B. Okay, and in this case, we're going to think about a specific tax, so a tax per unit that goes on firms in this market. And remember, with a tax per unit, we have a shadow, right? A shadow parallel shift in the supply curve to the left, right? Inwards. Okay. And so the idea behind this is we want to set a tax such that the shadow shift of the curve goes through that equilibrium, that socially optimal equilibrium, that equilibrium B in this case. Okay. And so what we want visually is a tax that's going to get us to basically this point where it's now that new supply curve intersects our socially optimal equilibrium B, right? And that's going to get us right to from the competitive equilibrium to the socially optimal equilibrium. Okay. And so that's how this tax actually works in practice. You don't actually have to fully replicate the marginal social cost curve with the tax. You just need to implement a tax such that when you add the tax to the marginal private cost, you're going through the socially optimal equilibrium. That's all that matters. Okay. Okay. And so to sort of derive the condition for the optimal tax, I will write that the tax, right? This is the optimal amount of tax per unit, T, is equal to the marginal cost, the social marginal cost at, I'm going to put the star here because the star denotes that it's the marginal social cost evaluated at the socially optimal quantity, right? And so this is actually a number. It's not a curve because I want to actually evaluate the marginal social cost at the socially optimal quantity minus the marginal private cost at the socially optimal quantity as well. Okay. And so the difference between these two things represents the difference between my marginal private cost curve and my marginal social cost curve at the socially optimal quantity. So it's basically this difference here, right? This red dot minus this purple dot, okay? That's the optimal tax because that is the difference between the marginal social cost and the marginal private cost at the socially optimal quantity, okay? And so what's sort of interesting and nuanced but important intuitively is this difference, the difference between the red and purple dots is actually equal to the marginal externality cost evaluated at the socially optimal quantity. Okay, it's just the value of the marginal externality cost at the socially optimal quantity here. Okay, and so you can also write the optimal tax as the marginal externality cost evaluated at the socially optimal quantity. Okay, and so when you're actually solving for problems like this, and you have a marginal externality cost curve, and you solve for the optimal quantity at the social equilibrium, you can just plug in that quantity to the marginal externality cost curve to determine your optimal tax. Okay, and we'll have some problems that look like that, definitely during the fall semester. And so when we say that we put a tax on the producer of a good that's producing an externality, we call that internalizing the externality. So you can forget this graph. We're not gonna. This graph was just meant to be the original graph and then adding the tax, but we've already done that on the original graph, so it's okay. And so when we tax the producer of a good that causes a negative externality, we say that the tax causes a manufacturer to internalize the externality, and that is to bear the cost of the harm that the firm is inflicting on others. Okay. In the case of a positive externality, you also are internalizing the externality, but by that, what we mean is we're actually compensating the firm or the consumer that's producing the positive externality, right? The positive externality, a classic example is like a farmer who has a honeybee farm that the farmer's bees go around to neighboring farms and pollinate the flowers, right? The neighboring farms are not paying the honeybee farmer for the bees to do that, um, but in fact that there should be some compensation generated to the honeybee farmer for producing that positive externality, because if they're not being compensated, then they're actually underproducing relative to the social optimum. Okay. And again, we're going to talk a lot more about this, and you'll start to develop a lot more intuition, but this is just to get you started on the structure for how to think about these things. Okay. And so we'll have some fun with the assignment during the synchronous discussion section. But other than that, that's the end of lecture 6, and I'll see you for lecture 7.